or a root nodes. When I consider a single nodes, this is also called a tree or a root nodes of the tree. Tree having must be ordered. Tree should maintain the order. When I consider a binary tree, it means that the ordered tree and each nodes must at most two children. These nodes having at most two nodes means 0, 1 or 2. 0 means no children, 1 means either left children or right children, 2 means left children and right children both. So I consider these nodes. I am naming this one 1, 2, 3. Again I consider another tree 1, 3 and 2. Suppose that this one is figure 1, this is figure 2. Tree should maintain the order. So these two trees are different. Why? Because for finding the order, we use the in-orders, pre-orders and post-order to verify these two trees are different or not. So that we used different method to find the ordering relations. So use this in-orders, pre-orders and post-order. For finding these things, use the tree walks or tree traversals, which is based on conventional methods and the converse methods. Conventional methods is when we traverse like this from the left side, first visiting the first nodes. When these nodes contain left childs, move to the left path, and the first time visiting the third nodes, and again check for these nodes left child is here or not. If there is left child, then move to left path. Otherwise, move to again same nodes. The second times this node again visiting. Then check for the third. It means right child. There is no right child, so back to this node only. Now back to this path to the previous nodes. This is the second time visiting. Again move to the right path, and this is the first time visiting of second nodes. Similarly, check for the left and the right. So no left path, so second time visiting, and the third time visiting again and back to previous nodes, and this is the third times. Now in orders means the second time visiting nodes sequence. So this is first times, this is second times. So this result is 3, 1 and 2. Three orders means first times visitings. So 1, 3 and 2. Post order means third times visiting. So 3, 3, then 3. This is the order. For this, in order is 2, 1, 3. Pre-order means 1, 2, 3. Post order means 2, 3, 1. Both having different sequence. For in orders, pre-orders and post orders. So we can say these two trees are different. So we should maintain order in a tree. It's compulsory. We should maintain the order. So both the trees are different. Now I consider a binary tree so that I am here considering binary tree. So question is, when we have in order pair, in order and the pre-orders, in order plus post order. Suppose we have in order and pre-order sequence, in order and post order sequence. This will give always a unique sequence, unique tree. Then we have post order and pre-orders. this may or may not be give the unique tree. So these questions can be examinations, GATE examinations already asked these questions. So when we find pre-orders and given in orders, we have to draw a tree and find the post orders. Now second questions, when we have n number of nodes at height h. Now the second question, when we have number of nodes at height h, we have to find the number of nodes at height h. We have a tree like this. I consider full binary tree, and we have to find at height h. At height h means this is level 0, this is level 1, and this is level 2. Similarly, we have to find h level. So that according to the height, to the power 0, to the power 1, to the power 2, to the power 2. When level 2, height to the power. So when height h, value is to the power h. It means that the last level, it means the leaf nodes contain to the power h nodes. So this one is the leaf nodes, suppose. So to the power h nodes contain at the leaf path, leaf nodes, and the internal nodes we have to find. When we add internal nodes and the leaf nodes, we get the total number of nodes. So we have to convert at the recursion forms when number of nodes at height h is equals to, we know already to the power h is the leaf nodes, and we have to find internal nodes. So what is the equations? We consider here h heights. Suppose that just before the h level we have h minus 1 level, so that we can recursively call n into h minus 1. This condition satisfied only when n equals to h which is greater than 0. Otherwise this equation is not true. Other way, we have to solve this height. We have to add these total heights to the power 0, to the power 1, so on to the power h. We have to use GP series, sum of GP series formula. So that formula is a into r to the power n minus 1 divided by r minus 1. A is the first terms, r is the common ratio, n is the total number of levels. So that a is 1, r is 2, common ratio is 2, n is h plus 1 minus 1 divided by r is 2, 2 minus 1 is 1. So that is to the power h plus 1 minus 1. At the height h, maximum number of nodes at height h, value is this one without the recursions, and this formula is using the recursion. So that we have to find total number of nodes in a binary tree. Now one more question arises here in a binary tree is, when we have n number of nodes, questions arises already asked in the GATE examinations, total number of nodes at the leaf is n. Question is, total number of nodes at the leaf nodes is n. How many total number of nodes? Question is, how many total number of nodes contain the tree? When we have n number of nodes at the leaf, then find the total number of nodes in a binary tree. So how to find the value? Already we know the total number of nodes is equals to the internal nodes plus the leaf nodes. Internal nodes plus the leaf nodes is the total number of nodes. So total number of nodes we have to find internal nodes plus the leaf nodes. Leaf nodes already n number of nodes. internal nodes already n number of nodes, and we observe here that leaf nodes, suppose in this case total number of leaf node is 4, internal node is 3, it means one less, so that internal node is n minus 1 nodes. Internal node is n minus 1, it means that total number of node is 2n minus 1, the total number of nodes in a binary tree, that is 2n minus 1. Okay, so the internal nodes whatever is given, or the leaf nodes whatever is given, total number of nodes we can find using this formula. The total number of nodes is equals to internal nodes plus leaf nodes. Okay. Now one more question arises here. What is the range? Suppose that this is not full binary tree. The question is, there is not full binary tree. Suppose this one is given. Then what is the total number of nodes? How to find? At height h. Obviously, I consider at height h. At height h, that is last level, that is not maximum nodes. I consider in between. So that the range is, already we know the total number of nodes, maximum number of nodes at height h, when all the nodes considered, when all the nodes are considered, the maximum number of nodes to the power h plus 1 minus 1, to the power h plus 1 minus 1, the total number of nodes. But here some nodes are missing at the last nodes, last levels, that some nodes are missing, so that we have to find just previous nodes, just the previous nodes, where is h minus 1 height. H height is not full completely, so we have to consider h minus 1 height. H minus 1 height considered full binary tree, so that to the power 0 plus to the power 1, so on to the power h minus 1 height. This value is to the power h minus 1. This result is to the power h minus 1. So that range is to the power h minus 1 to the power h plus 1 minus 1. It means last nodes, last node are not full. Then range is this one. Okay. So to the power h minus 1, total number of nodes lies between these two. Now, one more thing. Where we have a binary tree, the question is how many null branches in a binary tree? How many null branches in a binary tree? Suppose I consider as only 2 nodes. Okay, so I consider only 2 nodes to find the null branches. Null branches means the left and right childs which is not present as the leaf nodes. That left part pointers and the right pointers which is empty. So that for these nodes 2 null branches, and for this only 1 null branches. So that total number of null branches is 3. When I consider 2 nodes, null branches is 3. When I consider 3 nodes, we have 4 null branches. It means that total number of null branches is 1 more. It means n number of nodes, we get n plus 1 number of null branches. Okay, so thank you.